In 1869, the famous scientist Dmitry Mendeleev developed the first version of the periodic table of elements. Since then, it's been used all around the world. But today I want to explore an unexpected use for it. What would happen if you built a periodic table in real life? Spoiler, never try it at home. In today's video, you'll learn how dangerous chemical elements can be. I'll show you what happens if you set them too close to each other. Wear protective suits. This video from Riddle will be truly explosive. First, let's look at the periodic table itself. All of the elements in it are in order according to their atomic number, electron configuration, and recurring chemical properties. They're built in a special way. Rows in the table are called periods, and columns are called groups. To date, the table consists of 118 elements, although initially there were only 63. According to legend, the table first came to Mendeleev in a dream. Just imagine how strange it must have been. But enough of the boring theory. What would happen if you built this table from cubes made from the corresponding elements? For example, about 5 by 5 centimeters or 2 by 2 inches. In fact, this is quite possible. There are people who collect chemical elements. They try to collect as many samples as possible and put them in boxes. Even in some schools, you can find things like this. Some of the items can simply be purchased in a store. For example, helium, carbon, aluminum, iron, or sulfur. These won't be a problem. Other elements can be obtained with a little effort by breaking some devices. In fact, elements can be found in the most unexpected places. A sample of americium can be found in a smoke detector. Others can be ordered online. You'd be able to collect about 80 elements. If you risk your health just a little, then 90. However, it may not be entirely legal. In any case, you wouldn't be able to collect every element from the entire periodic table. Some are too radioactive or short-lived. But let's assume that you're in ideal conditions in some laboratory, and somehow the elements could be built into a real table. I won't dwell on every element. I'll take into account only the most interesting ones. What would happen? The very first cube would be made of hydrogen. It's gas, so it would just float away and dissipate. The same would happen with its neighbor, helium. The first row is quite simple. The second row is a bit more complicated. A cube of lithium would immediately darken in the air. Beryllium is quite toxic, so it would need to be handled carefully. Cubes of oxygen and nitrogen would slowly melt in the air, gradually disappearing. Pale yellow fluorine wouldn't retain the shape of a cube at all. It would immediately spill onto the floor. By the way, fluorine is a very aggressive element. Additionally, it's a strong oxidizer. It can set fire to almost anything in its path. It should be kept away from other elements, except perhaps chlorine and neon. The latter, by the way, is lighter than air. The neon would have long since flown to the ceiling. The reaction of fluorine with other elements would be violent, and its contact with the human body is fatal. We haven't even reached the radioactive elements, but we're already risking our lives. The third row. Here, you should be afraid of phosphorus, but it depends on the kind that you come across. Red phosphorus is relatively safe. White flares up on contact with air and burns with a hot flame that's difficult to extinguish, and it's poisonous. Are you wearing a protective suit? And now sulfur. Usually this just smells bad, but in our table, it's sandwiched between burning phosphorus and fluorine with chlorine. Upon contact with fluorine gas, sulfur also starts burning. Nearby is the inert gas argon, but this would just spill onto the floor. And this is the least of our problems. A fire is raging in the table. As a result of the burning, there's also smoke. If you built the table in a closed room, soon you would probably suffocate. There are too many toxic fumes, and your lab might burn down. Let's say you managed to survive the third row. Let's move on to the fourth. Arsenic is quite toxic. In very small quantities, people can easily handle it. But burning phosphorus, along with potassium, which would also be burning, could ignite the arsenic. The resulting chemical would be arsenic trioxide. It's poisonous. Don't breathe it in. However, not only because of the arsenic, selenium and bromine would also react violently, and they just smell awful. By the way, I didn't mention aluminum. It was in the third row and may have survived the fire. But if it touches gallium, it turns into something like cardboard. It could be broken with one finger. Meanwhile, the sulfur would continue burning and touch the bromine. It's liquid, but very toxic. Even at low concentrations, bromine vapors can cause nosebleeds, dizziness, and mucosal irritation. If there's a lot of bromine, a person would simply suffocate. Even a gas mask wouldn't help. And now we're only at the fifth row. Here we're dealing with technetium, the first radioactive element. However, a cube of technetium definitely wouldn't kill you. I mean, if you just place it on the table. The sixth row contains several radioactive elements, including promethium, polonium, and radon. But the most interesting is astatine. This is the rarest member of the periodic table. In nature, it's almost negligible. And artificial astatine isn't possible to create due to its radioactivity. Any large piece of it would quickly evaporate in its own heat. But let's say we managed to make an entire cube out of astatine. It wouldn't last long, and it would turn into a column of incandescent gas almost instantly. The heat alone would cause third-degree burns to anyone nearby. The building where you built the table would be destroyed to the ground. If it was still intact, a cloud of hot gas would quickly rise into the sky, emitting heat and radiation. Then, the remains of the house and table would fall to the ground. It would be debris covered in radioactive elements. The resulting rain would destroy life in at least the nearest neighborhoods. You and everyone around you would receive a lethal dose of radiation. No one would survive. But the table itself still isn't finished. Let's imagine that there was no column of incandescent gas. There are elements called transuranium elements. Most of them are very unstable. They can't exist for more than a few minutes. If you had 100,000 atoms of livermorium, in just 1 second, you'd have only one left. Then it would disappear too. But this doesn't mean that transuranic elements simply dissolve. They disappear in the course of radioactive decay. So the cube of such an element would disintegrate in a few seconds, and it would leave a huge amount of energy in its place. Do you understand what this means? Instantaneous nuclear explosion. The flow of energy would turn you and the rest of the table into plasma. What would happen would resemble an explosion of a medium-power nuclear charge. But don't let out your breath yet, because the consequences would be 1,000 times worse. Not only would nuclear fallout descend to the ground, but every other element that was in the table would as well. Elements would turn from one into another with incredible speed. It would be like a nuclear bomb that keeps exploding, again and again and again. What conclusion can I draw from this? Collecting is an interesting hobby, but it's better to choose something like stamps. If you like this video, give it a thumbs up. Don't forget to subscribe to the channel if you haven't already, and click on the bell to receive timely notifications about the release of new, interesting videos that are waiting for you ahead.